In this video we are going to tell you about space debris in human spacecraft. More than 27,000 pieces of orbital debris, or space junk, are tracked by the Department of Defense's Global Space Surveillance Network, SSN, sensors. Much more debris too small to be tracked, but large enough to threaten human spaceflight and robotic missions exists in the near-Earth space environment. Since both the debris and spacecraft are traveling at extremely high speeds, approximately 15,700 miles per hour in low Earth orbit, an impact of even a tiny piece of orbital debris with a spacecraft could create big problems. The rising population of space debris increases the potential danger to all space vehicles, including to the International Space Station and other spacecraft with humans aboard, such as SpaceX's Crew Dragon. NASA takes the threat of collisions with space debris seriously and has a long-standing set of guidelines on how to deal with each potential collision threat to the space station. These guidelines, part of a larger body of decision-making aids known as flight rules, specify when the expected proximity of a piece of debris increases the probability of a collision enough that evasive action or other precautions to ensure the safety of the crew are needed. Space debris encompasses both natural meteoroid and artificial, human-made, orbital debris. Meteoroids are in orbit about the Sun, while most artificial debris is in orbit about the Earth, hence the term orbital debris. Orbital debris is any human-made object in orbit about the Earth that no longer serves a useful function. Such debris includes non-functional spacecraft, abandoned launch vehicle stages, mission-related debris, and fragmentation debris. There are approximately 23,000 pieces of debris larger than a softball orbiting the Earth. They travel at speeds up to 17,500 miles per hour, fast enough for a relatively small piece of orbital debris to damage a satellite or a spacecraft. There are 500,000 pieces of debris the size of a marble or larger, up to 0.4 inches, or 1 centimeter, or larger, and approximately 100 million pieces of debris about 0.04 inches, or 1 millimeter, and larger. There is even more smaller micrometer-sized, 0.000039 of an inch in diameter, debris. Even tiny paint flecks can damage a spacecraft when traveling at these velocities. A number of space shuttle windows were replaced because of damage caused by material that was analyzed and shown to be paint flecks. In fact, millimeter-sized orbital debris represents the highest mission-ending risk to most robotic spacecraft operating in low Earth orbit. In 1996, a French satellite was hit and damaged by debris from a French rocket that had exploded a decade earlier. On February 10, 2009, a defunct Russian spacecraft collided with and destroyed a functioning U.S. Iridium commercial spacecraft. The collision added more than 2,300 pieces of large, trackable debris and many more smaller debris to the inventory of space junk. China's 2007 anti-satellite test, which used the missile to destroy an old weather satellite, added more than 3,500 pieces of large, trackable debris and many more smaller debris to the debris problem. The Department of Defense maintains a highly accurate satellite catalog on objects in Earth orbit. Most of the catalog objects are larger than a softball, approximately 10 centimeters. NASA and the DoD cooperate and share responsibilities for characterizing the satellite, including orbital debris, environment. DoD's Space Surveillance Network tracks discrete objects as small as 2 inches, 5 centimeters, in diameter in low Earth orbit and about 1 yard, 1 meter, in geosynchronous orbit. Currently, about 27,000 officially cataloged objects are still in orbit and most of them are 10 centimeters and larger. Using special ground-based sensors and inspections of returned satellite surfaces, NASA statistically determines the extent of the population for objects less than 4 inches, 10 centimeters, in diameter. NASA has a set of long-standing guidelines that are used to assess whether the threat of such a close pass is sufficient to warrant evasive action or other precautions to ensure the safety of the International Space Station and its crew. These guidelines essentially draw an imaginary box, known as the pizza box because of its flat, rectangular shape, around the space vehicle. This box is about 2.5 miles deep by 30 miles across by 30 miles long, 4 by 50 by 50 kilometers, with the International Space Station in the center. When predictions indicate that any tracked object will pass close enough for concern and the quality of the tracking data is deemed sufficiently accurate, mission control centers in Houston and Moscow work together to develop a prudent course of action. Sometimes these encounters are known well in advance and there is time to move the International Space Station slightly, known as a debris avoidance maneuver, to keep the object outside of the box. Other times, the tracking data isn't precise enough to warrant such a maneuver, or the close pass isn't identified in time to make the maneuver. In those cases, the control centers may agree that the best course of action is to move the crew into the Russian Soyuz or U.S. commercial crew spacecraft that are used to transport humans to and from the station. This allows enough time to isolate those spaceships from the station by closing hatches in the event of a damaging collision. The crew would be able to leave the station if the collision caused a loss of pressure in the life-supporting module or damaged critical components. The spacecraft act as lifeboats for crew members in the event of an emergency. Mission Control also has the option of taking additional precautions, such as having the crew close hatches between some of the station's modules, if the likelihood of a collision is great enough. Debris avoidance maneuvers are planned when the probability of collision from a conjunction reaches limits set in the flight rules used to operate the space station and the spacecraft used to transport humans and cargo to and from the station. For the space station, if the probability of collision is greater than 1 in 100,000, a maneuver will be conducted if it will not result in significant impact to mission objectives. If it is greater than 1 in 10,000, a maneuver will be conducted unless it will result in additional risk to the crew. Debris avoidance maneuvers are usually small and occur from 1 to several hours before the time of the conjunction. Such maneuvers with the space station require about 5 hours to plan and execute using the station's Russian thrusters, or the propulsion systems on one of the docked spacecraft. The International Space Station has conducted 29 debris avoidance maneuvers since 1999, including 3 in 2020. In 2005, NASA implemented a similar process for selected robotic assets such as the Earth Observation System satellites in low Earth orbit, and the Tracking and Data Relay satellite system in geosynchronous orbit. In 2007, NASA extended the conjunction assessment process to all NASA maneuverable satellites within low Earth orbit and within 124 miles, 200 kilometers, of geosynchronous orbit. The U.S. Space Force's 18th Space Control Squadron, 18 SPCS, is responsible for performing conjunction assessments for all designated NASA space assets in accordance with an established schedule, every 8 hours for human spaceflight vehicles and daily Monday through Friday for robotic vehicles. The 18 SPCS notifies NASA, Johnson Space Center for Human Spaceflight, and Goddard Space Flight Center for robotic missions, of conjunctions that meet established criteria. The Space Force tasks the Space Surveillance Network to collect additional tracking data on the threat object to improve conjunction assessment accuracy. NASA computes the probability of collision, based upon missed distance and uncertainty provided by the Space Force. Based upon specific flight rules and detailed risk analysis, NASA decides if a collision avoidance maneuver is necessary. If a maneuver is required, NASA provides planned post-maneuver orbital data to the Space Force for screening of near-term conjunctions. This process can be repeated if the planned new orbit puts the NASA vehicle at risk of future collision with the same or another space object. Credits. For additional information visit NASA's website. Thanks for watching Space View channel. For more related videos please visit my channel link given below description.